Hey, welcome back to Mini Rust in Rust. This is video 42. We're building a little programming language that's so far got the same syntax as Rust. We're writing all the code in Rust, which could get confusing. But yeah, it's really just for fun, just to see like how a programming language comes together. And what we're actually trying to do is some type checking. What we're trying to say is if I make a variable which contains 3, I can't treat it as a Boolean by putting it in a while condition. But we hit a wrinkle last time, which is that we got this weird parse. I got curious about this weird parse of what if there is an opening brace somewhere in our while condition, even though we said parsing a while condition should stop when we hit an opening curly brace. And I said it should be fine, because at this point when we hit this opening curly brace, we're in the middle of parsing this operation. So it should work. And it didn't work because parsing operations is not clever enough yet, I think. So that's what we're going to try and fix. That's what we're going to try and fix. And I'm not sure how it's going to go, but we'll see. All right. And also, I'm a bit curious about what happens if there's an opening curly brace in the beginning, because that also didn't work. So if we can make progress with either of those, we will. So let's enable this test. And it complains because this 3 was unexpected, because it's basically, I think, expecting just a single token when it's parsing less than or equal. So I guess we can check that by just writing ourselves another test for less than or equal. Which I guess is going to look something like this. So let's just put the 7 in a block. So this would be parsing comparison handles non-token right hand side, or not token on right will be this, using a weird English idiom. So that's going to look like it's going to parse as 28 on one side, although we always change it, don't we? So 29 on one side. I won't change the number of digits because it gets annoying. In fact, this is already wrong. It's already wrong. We've moved that 8 along 2 characters. Like so. But actually, this is a block. So syntax tree block, which I guess takes like a slice of things, but we'll check that in a second. Something like that. I've got the wrong number of brackets. So it's a leaf containing an int, a box holding onto that, slice, close the block, close the box. That was it. There we go. Right, so complaining because block takes in a vec, not a... Oh, block takes in 2 things. It takes in a vec of all the statements, which should be an empty vector, followed by just one thing, which is the final expression, which means... How many things did I delete? Felt like I deleted 2 things. Obviously not. Yeah, this is how it should parse. It should parse to be a number followed by a block containing an 8. Well, the 8, let's say. So when I run that, it fails because it wasn't expecting a curly bracket there. So it's different. Interesting, it's a different error. Let's see whether we fixed both of them by fixing parsing of operators, maybe. So an expression might consist of various things. For example, a leaf or an operation or a mutation. And if it's an operation, yeah, so this is going to need to get better because it's looking for just one token on the left-hand side. So we're going to need to be a bit smarter about how we parse the left-hand side, but let's focus on the right-hand side. So we know it's an operation. We got hold of the operator token. It was less than or equal. And so now it's the right-hand side of an operation should be, instead of just finding a leaf here, it should be, I guess, the right-hand expression should be just some kind of expression. And we're passing these end markers to say when you know that you've finished the expression. And I guess we question mark it. And we don't have to do this anymore. That comment is, I guess, still about right. Okay, so the expression doesn't return a result. So I guess if expression returns none, that means we hit the end of the input string, I guess. So that will mean that we should somehow change this to unwrap or else some kind of error, right? So it'll be, if it all goes wrong, we're going to return error on, oh no, it's a miet error. Okay, so we need to do some kind of miet error here. Right, so where do we make miet errors? Okay, we can do something like missing expression. All right, so we've already got some error types, and I think there must be one that's already unexpected EOF, for example, which takes some things. So it takes in source, which I think is going to be, we've kind of just cheated by putting in a fixed thing here. And the label, what do we do in this other error? It's going to be like the end of the file. We just need to point at the end of the file. So I guess that would be the position of operator token. So where do we do things like that? Yeah, so it'll be like token.span.clone.into, right? Something like this. Maybe just span. Can we just use the span? Let's see. So it's going to be the operator token, because that's like the last thing that we actually had. Just like that, maybe. And we have to call into on this to turn it into a miet error. Maybe without wrapping in error first. Like that. Yeah. And then if we call into on that span, it makes a label. Okay, so just to explain a little bit, so I was thinking too hard to talk properly. So we're parsing an expression. If it all goes wrong, then we construct this error. We need a question mark here. So I guess maybe an if let would be, maybe a let would be better with a return. That question mark's a bit hidden there. So then we can just say else, using the classic let else thing, and we're going to return this error if it all goes wrong. That's probably a bit better. Yeah. So now we parse an expression. If it all goes wrong, we say we hit the end. Sorry. If it all goes wrong, if it returns none, that means we hit the end of the file without finding an expression, which is unexpected end of file. So we say we hit the end of the file, and the span that we give is essentially the operator, because that's kind of the last thing we found in the file. And this thing exists now. We can say the right-hand expression is that. But so far it's a result of parse. Okay, so expression returns a result of option, or an option of result. Let's think about that in a second. Yeah, expression returns an option of result. So, if it's unexpected EOF, then we return. Otherwise, I think I want to separate this out. So just say. Also, if it was an error, then bail out here as well. I'll just separate that out instead of putting the question mark here to make it easier to read. But now we've got a problem. The problem is, oh no, we haven't got a problem. Previously we were getting a leaf and we had to wrap it up as a syntax tree. Now we've got a syntax tree, we can just pass it in. Okay, will this make our tests pass? That's looking pretty good, because it looks to me like it's all parsed okay. It just, we haven't correctly written our test to say what it actually parses into. So let's look this up. Line 1180. Yeah. So we've incorrectly said what's in the block. So it should parse into a while loop where the condition is an operation of a blah de blah and then an empty block. Yeah, so this should be, let's just break this up a bit. This should be a syntax tree, which is a type operation, and the operator, let's get this right. The operator is an operator token, so let's make an operator token, and it's going to be less than or equals, and it's where it is in the actual document is from 0, 1, 2, 3, 4, 5, 6, 7, 8. It's from 8 for 2 characters, and it consists of the left and right sides of this operation are a thing which is actually the same as this thing. So let's paste it in. What's this bracket? I think the bracket's still needed. And then the right hand side is itself going to be a block. So again, box, hang on, have I closed my box new? Yeah. Yeah. It's going to be a box containing a block. This gets complicated. It'd be nice if I could sort of represent this in a way that was neater looking. Maybe we just need a few functions to simplify how this looks in our test, and it will be a lot nicer. Okay, so this is a block of statements, which is a vec, followed by a final expression, which again is going to be a syntax tree of type leaf token. No, it's going to be of type leaf, which contains a leaf token, which is a integer, and it's be for 8, 9, 10, 11, 12, 13, 14, 15. And in the vec, this is going to be, what is this? It's a vec of, vec of box of syntax tree, right? So in here is another syntax tree. Again, it's a leaf. Oh, is it going to be a statement? I think it's going to be a statement containing a, let's see. So this is a leaf token, it's 1, 2, 3, 12 to 13. So did it have a statement? Yeah, it had a statement inside, so let's put that too. So of course, everything inside a block, except the last thing is in final expression, but everything else inside a block is a statement. So this is actually going to be a statement and a statement just holds on to an expression, which is the expression we've already written, hopefully. And I've done my brackets wrong. I missed one. And I put an extra one in the wrong place somehow. Okay, now it's going to work? No, because how would anyone get that right first time? Okay, so it's an operation less than or equal, span from 8 to 10, followed by a leaf token of kind int spanning 6 to 7, followed by a right, which is syntax tree of unit. And then a block. So is this parsed wrong? I think this is parsed wrong. Yeah, there's 2 blocks. And this one is outside of the while, I think. Yeah, this is like after the while, you've got another block. So this block has not gone into here. It should have been... It stopped parsing because it hit a curly bracket. Okay, so I think what's happening here is that in the middle of parsing this, we passed down you should stop parsing if you hit an open curly bracket, so that even the parser of expressions for the right hand side of less than or equal is already saying you should stop parsing if you hit an open curly bracket, and that's not right. So actually, when we're parsing an operation, the right hand side of an operation, we shouldn't stop based on what something else cares about when it should stop parsing using these end markers that it was using. We want to give it our own set of end markers, which is probably like nothing at all. But then how do you know to stop? I feel like sometimes parsing is greedy and sometimes it's non-greedy. Oh, it's really difficult, this, because it's not even that. Like, you have to actually parse the thing you're looking at, figure out whether it is an expression. No, how does this work? Like, how does... for us to know to stop. Yeah, it must be. Yeah. It must be. You'd parse in some way. You back off. So if the thing wasn't a plus or some other operator, you back off. All right. So it might be as simple as we might already have done this. So when we ask for the right operand, we're not going to reuse our end markers. We're going to make a new end markers, which let's for now say is empty. Because the end markers of ourself are not relevant to this. Let's see what happens. Okay, so what happened was we broke some other stuff, which was a while loop that does contain an expression. In fact, we broke a load of stuff because it just carries on parsing and never stops. And it doesn't know what to do with a semicolon. So I guess the point is, when we hit a semicolon, we should back out and say, okay, it's not that we don't expect this semicolon, it's that this semicolon tells us we're no longer parsing this expression. We've finished, and we need to back off and give that semicolon to someone else. So let's have a look at how expression works, because we might be just getting to the difficult bit of parsing here, and whether we can fix that in this video is a good question. So, when we're parsing an expression, we grab a token and we say, if that token is something we should stop on, then stop. Otherwise, it kind of means, why don't we just pass in semicolon? Still not going to fix our case though, because we need to stop, not because we hit something we know to be an end marker, but because we hit something that doesn't make sense after a kind of complete expression. So let me dig into that a little bit. So when we go into, it's either a leaf or an operation or a mutation, or it's unrecognized. And we grab a leaf token. If we get a leaf token, we know that there's something after now. And it could be just a leaf, or it could be an operation, or it could be a mutation. So we get the next token, and we say if it's an end marker, stop. Otherwise, if it's an operator, continue. Otherwise, it wasn't an operation. And what we're saying is it must be a mutation. But the other thing it could be is that we are just done with parsing. And so we should back off. We should push the tokens that we grabbed back into the queue and just say, I've finished parsing. So what's the simplest possible test case we can come up with for this? So I guess it would be something like a while loop. Where, it's not even as simple as that though. Like we have to kind of parse the whole thing. No, we don't. Yeah. So an example of this, let's just mark my place here so I can come back. Example of this is the while loop. Like this. So the point is, when we hit this opening curly bracket, it's not that opening curly brackets are banned. It's that hitting an early open curly bracket here does not indicate that we're continuing with an expression. Instead, it indicates you've finished parsing this expression, and this is just whatever comes next after that. So back to where we were. That means that I've said it must be a mutation, but that's not right. It could be a mutation, or it could be the end of what we're doing. And then I hit this question mark, and check token of type returns a met error if it went wrong. So I guess we should say try from token instead. And this should be another if let OK. So let's try that. So this would be else if let OK mutation token equals try Are we cloning token too many times? Maybe. So now we can say must be an operational mutation or we are done. Is this going to absolutely screw everything up? We'll have to wait and see. So we're going to do if let, and we got a hold of our mutation token. So that's just like it was a mutation. Or like, I guess it's like we have a mutation. We have a mutation. Otherwise, something else. And here this should be... Okay, so this is an operator token and it's expecting mutation token. Hold on. Yeah, this should be mutation token here. Yeah, I copied the code above because I wasn't thinking about it. So basically this is saying try and make me a mutation token. And if you do come into this, like you get return a sum, so we return OK, so we come into this. Otherwise, we'll return some kind of you didn't get a mutation token, so that's fine. We'll come into else, and else will return. Okay, it should return none, and it should push some tokens back, I think. But yeah, let's just say it returns none, which means that everything else needs to be optional. We're too nested here, aren't we? But yeah, so let's make this return an option. And that means everywhere else we need to wrap it in a sum. Like so. And we should probably have broken this mutation code out into its own function as well. But we haven't yet. Hold on. This should be a result of option, not an option of result. Surely. Yeah. Because like errors we should just bail out on. So now this means this should be an OK sum. And that means, I guess, this operation, right operand thing should also return a result of option, otherwise it gets awkward. Even though it's always going to be sum. But otherwise we'd have to kind of wrap it in a sum when it came back, which would be pretty annoying. That's the same function being called again, right? Isn't it? No, it's not. It's a similar sounding function. Do the same for this. where did we get to? So this is going to be now an OK none, and I need to explain that. It's basically we found a token that does not continue an expression. And that's a little odd because a mutation is not really an expression. Yeah. Okay, well, we'll deal with that. If it breaks a load of stuff, we know it's broken a load of stuff. Right, so what we've managed to express so far is previously the only thing it could possibly be if it wasn't an operator token, because we're partway through parsing an expression, we found something else, and it's not one of our end markers. So it must be a mutation token, but what we're saying now is it's either a mutation token, like as in like plus equals or something like that, or it's just something unsuitable, and we should bail out and say, yep, that's not part of our expression. We finished our expression. Is none the right thing to return here, or should we return the leaf token, like the first thing? Okay, so now we need to decide what happens. I guess this also... No, maybe we should just return leaf token wrapped up as some kind of syntax tree. Like, so leaf was like the left-hand side of this thing. So eventually this is going to have to not be a leaf. It's going to have to be some kind of syntax tree of its own, like the left-hand side of an operation. But for now, let's just imagine it's a token. Let's just do things one step at a time. So yeah, I think we need to return a syntax tree that wraps that leaf token exactly as we've got below. So it's exactly the same. What are these two cases? Either we hit an end marker. So if we hit an end marker, it's the same as if we hit just some other token that we don't know about, except we should push this token back into... So self.tokens is a backtrack obliterator, which means we're allowed to push things back by... How do we do that? Is there some kind of... Right? The tokens is a backtrack obliterator. What do you do with backtrackable? Oh, you give back. So basically we pulled out a token that which is called token that we thought might be useful for extending this expression. It wasn't, so we just put it back. And in this case there's only one thing to put back, I think. So that's okay. Okay, and I'm kind of wondering, do end markers no longer exist now? Instead of end markers, it's just like any token that wasn't part of parsing this expression. So maybe we don't need end markers. That would be a really nice outcome. All right, so why are we going wrong? We're going wrong because we don't need to return an option. I put in loads of options, and now we've figured out what we're returning. All right, so we go back, we fix it. And we fix this, because this doesn't need to return an option either. I mean, it's good. We're returning the thing we were given. Instead of some kind of magic marker called none, which tells us that we're done. It's like, no, you gave me the thing, the left-hand side, so I'm returning it. That's the whole expression. But we embedded this pattern in a few places. This might be the last one. So, right. Is everything's compiling. How many tests have I destroyed? Only 2 tests failed. And that one, at least, is one of our new ones. So that's, I suppose, good. And look, the right-hand side is a block. So are we only disagreeing on where we think that integer is? Yeah, these two are off by 1. So let's fix that one first and then go back and figure out why my other test is failing, because this is really encouraging. Containing open brace, that was it. Alright, so we just got these off by 1. I think I can trust Rust to count better than me, so I won't double check that. And look, our test passes and we've just got 1 left, so let's have a look at parsing 2 adjacent numbers is an error on 1206. What would be really great would be if the new code is better than the old code. So, okay, it's no longer an error because parsing this just is fine. It just says there's an 8 and then I finished that expression and now I'm looking for another expression and it's 21. So this is where I feel like we should actually be looking for statements, not expressions, to make this test pass, because 8 semicolon 21 should pass because that's a statement followed by an expression. But this should fail because once we finish this expression, that's fine. But what should come next? The only thing that should come next is a semicolon, right? Because, or the end of the file, because you can't just write 2 expressions next to each other. Except, of course, if it's a while loop followed by something when you can. So if we fix this in the wrong way, we'll probably break that. But, alright, so, okay. So I'm almost inclined to ignore this test and say what we've got now is better than what we had before. But let's think about whether we can fix this test, because this should fail. It should fail, and we've broken it. So, when we parse, we look for an expression terminated by a semicolon. What we should do is look for a statement. So, I don't think there is a method called statement. Actually, should we though? Because that's not quite right. That's not quite right. Because the last thing that we parse is not actually going to have. This to-do's gone. Like, this constructing this semicolon is no longer awkward. Fine. So what we're looking for is an expression which is either the end or has a semicolon after it. So, here we go. So, every time we're parsing, we look for an expression, and if we've got an expression, that's fine. Now we look for another token. If there's no token, we're done. Yeah, so this was, look for an expression. If there's an error, quit. Otherwise, we've got an expression. Now look for the next token. If there's no token, we're done. If there is a token, if it's a semicolon, it's fine. We've got a statement. Otherwise, give back the token and return the expression. And I think that's wrong. When we parse, there should be a statement, or this is an error. I think. So, let's test my theory by saying otherwise it's an error. Now this is a Miet error. Well, it's an... Why is this an option? When could we return... Oh, hold on. Because if we get to the end of the... Yeah. Oh, because expression itself might return... No, we quit out here. So, right. So, don't think about that. So, we're going to return sum already because the sum's here. But this is going to be an error. We're going to call a .into to turn it into a Miet error. And it's going to be unexpected token. Like that. Now, why is into sad? Oh, because I put it on error and I should have put it on unexpected token. Yeah. So we got, where can I copy from? Here we are. I mean, unexpected token would be a good one to copy from. So let's copy this. So it's got a source, which is the same source we always use. It's got a label, which is essentially this token. This token has a span. And the token, let's look for where we did this before. But yeah, we need to get hold of the str form of the token, which we need to do before all of this, which is a bit annoying. Oh no, we can do it only in the error case, at least in this situation. Yeah. Should be token.span. Yeah, so, all right, let's try. I don't know. Is this going to make a load of tests fail? Yes. Ah, okay. It's the case that I predicted. It's the while case. Another while. All right. So good. So we did some kind of special handling of an expression after a while is okay. I wonder what we did for that. I've totally forgotten. But now we've got this new situation, which is essentially, if our expression was a while expression, it's allowed to have an expression after it because it's allowed to kind of effectively pretend to be a statement. Like while expressions and others that we'll get to, I guess, like loops and things, are allowed to be non-semicolon terminated expressions. So blocks are another good example when we get to that. So if there's a semicolon, we're fine. We've made a statement. We're done. Otherwise, if our expression is allowed something, otherwise we were not expecting this. So if this is allowed to be, if this statement, if this thing that the expression we've found is allowed to be a statement, so I guess it's expression can be statement, something like that. So let's make our function. Maybe this will be really easy, like there'll be a particular type of expression which, why is it annoyed? Oh, we should pass in a reference to that expression. Let's comment this. No, this. So basically, I guess for now, we're just going to match on. Oh, in fact, we could use the matches macro. No, I think a match statement is going to be clearer. Well, I think Clippy's going to get annoyed with us. We'll see. Right, come on. Why won't you? I'm pressing the keyboard shortcut that should offer me to fill in the match arms, and it's failing to do so. How annoying! So syntax tree. What are the types? Oh, it must be failing because syntax trees. Oh, it's syntax trees node that I'm looking for. So there we go. Okay, it's a syntax. There's a load of syntax nodes. Oh gosh, that's got a bit messy, hasn't it? So reference to the syntax node inside our expression has various types. So can a unit be a statement? I think no, nor a leaf, nor an operation. So all of those. Whatever's inside the leaf, or whatever's inside the operation. And I guess also an assignment is also no good. And what about a mutation? Mutation statement can't be an expression. It's basically anything that ends with a curly bracket that is allowed. None of these end with a curly bracket. Statement is kind of irrelevant, so I guess we'll just say it can be. And while and a block also can be. So let's just say with all of these. So this will be false. I think Clippy's going to get annoyed with me, and I'll let Clippy suggest. But I think what Clippy suggests might be a complete horror. So, yeah, we'll see. So, the nice thing about putting this in a match statement is if I add new types later, the compiler will tell me I've missed some. And I'd quite like that. So, is that just going to make our test pass? Oh my goodness, all our tests pass. So we've ignored variable with wrong type as an error. We've ignored assigning incompatible types as an error. Is that new? I don't think that's new. How many have we ignored? Only ignored 2. So, okay, so we're doing amazingly well. So, okay, so this is fantastic. I think we've really made a step forward with our parsing, and I feel like maybe end tokens are no longer needed at all. Is that what they're called? Do I call them end tokens? End markers. I feel like maybe end markers are not needed, which would be totally cool, because essentially, like anything you meet which can't be the continuation of expression means I've finished parsing this expression. So let's try deleting this end marker and see whether any of our tests fail. Okay. So, I mean, maybe is semicolon a special case? Like if you hit a semicolon when you're expecting an expression, you should return an empty statement, I guess. So, maybe that's still a thing. So let's have a look at where else we pass in end markers. So, for example, here, a closing brace is also asked for. So what if we just didn't do that? I feel like our new code makes this all just still work. No, that really badly doesn't work. Because there's a load of places that, okay, so maybe end markers still make sense. Do end markers still make sense? These two cases seem like they make sense still a bit. So, okay. So interim conclusion, maybe end markers still make sense. So the other loose thread that I feel like I want to try and pull on slightly is, before we have some kind of sum up of what on earth I've actually done, is that I feel like we put in some special code when we made while statements be allowed to have something after them. So maybe the best thing to do is look at what we did. So parse while conditions, that's what we've just done. Type checking while, that's the type checking. Evaluate code that is enough for a while loop. Okay, that's evaluated code. And then we've got type checking a while loop. Allow while loops to have bodies. Lex and parse empty while loops. Okay, so allow statements to end without a semicolon. That is the thing I'm thinking of. So what did we do? We had previously. Oh, okay. Okay, so actually it's the code that we're now editing again that had this special code saying it has to end with a semicolon. All right, so I actually think if that was the only special handling we had for while loops not having to end with a semicolon, then I think we're done, because all we've done is expand that code to allow for like the fact that our parsing might have gone past the end of, well, to allow for the fact that there might just be an expression next. So I think we've done a good thing. Let's take stock. I mean, we definitely haven't made our test. Oh, maybe this might be one more test that we can add. Oh no, we're not going to make it past this time. I think we've got enough. We've got enough for a video here. So, that's the last thing we did. So let's start with the first thing we did. Hang on, I did something with end markers that I might no longer agree with. I mean, I think quite a lot of the places where we pass in end markers, we shouldn't need them. Yeah, where did I edit the end markers that were getting passed in? Oh, I didn't. Look, it's back to being just whatever you gave me. I feel like that might be wrong. But all my tests are passing. So if it is wrong, we'll find out about it when we write the relevant test. Okay, so here's the situation. Previously, before this video, we had found this weird edge case where, and we thought we could make it work, but we found this edge case where like an opening curly brace can be part of a while condition. And we won't hit our thing of end marker including an open curly brace because we're partway through parsing an expression at this point. Now, have I actually deleted that place where I added an open curly brace to our list of possible end markers? I'm just curious about whether we've still got this. It was up, right, up, around. No, it's a while as well. When we're parsing a while loop, the condition expression now just asks for an expression. We pass in end markers, but we also pass in brace open as one of our places to stop. Now, what if we didn't do that? I know we've got an extra ampersand there, but it'll let us off with that. So still passes. So basically that hack that we added in of saying stop parsing if we hit an end curly brace is no longer needed, because we stop parsing when we hit an end curly brace because that's just not continuing an expression. So we should also think about other places where we're using end markers, and we don't need to anymore. But having said all that, we'll continue with our diff. If I regret that, we can put it back in later. So we had a test of a weird situation with the expression for our while loop containing an open brace, but we thought it was okay because we knew that we weren't finished yet because we're partway through an operation. So now we're unignoring this test because we were right that this does indeed work, because it knows we haven't finished. It knows it's expecting more expression because we've had this less than or equal. We had to fix up the test to make it actually be correct, but it now passes. Also, this other test that we've created, which is basically saying there's something on the right-hand side of an operator that is not just one token, and now that used to fail, now it passes. And the way we did it was, how did we do it? The way we did it was this stuff. When we're parsing something that might be a leaf or might be an operator or might be a mutation, then what we did before was here's where we're not passing in any end markers anymore, and we used to be, which I guess is fine, right? At this point, let me think about that. At this point, we could just pass in end markers and I think it will still work. So what's the logic here? We've seen that an operation is happening because we've got an operator token. And we want the right-hand side of the operator token. And the question is, do we stop when we see like what we're expecting to tell us we've finished, like a closed curly bracket? Or will hitting a closed curly bracket just make us stop anyway because it wasn't an wasn't a token we expected? I think the answer is we will stop. And maybe end markers are pointless here, but I don't want to make that change in this commit if I don't have to. So let's put it back to how it was. So let's go to line 263. This is why we review our codes before we... What? 263? Of what file? No, it's a bit further down, 263. It's here. Yeah, so put the end markers back in. In fact, no, not like this, like this. Okay. Still passing? Yes. Okay. So, back to our diff. We were just slightly lost by why that diff was more complicated than it needed to be. So yeah, what we were saying was the way this works is previously when we were looking at either a leaf or an operator or a mutation, then when we found an operator, we just did our thing. Otherwise, it wasn't an operation. It must be a mutation. And instead of that, what we said is, okay, it's not an operator. Is it a mutation? Is there a mutation token here? Yes, therefore we're doing mutations. Otherwise, we just found a token we weren't expecting. So it could be anything else. We could be in the middle of all kinds of stuff. But it's not a token that tells us this expression continues. So we put the token back and we just return you the expression that we've calculated for you. And that's it. So that's the kind of core of the change. Also, when we're parsing the right operand of an operator, instead of just looking for a single token on the right hand side. So I guess this is also the change, right? Instead of just looking for a token on the right hand side, we're looking for a whole expression. And if we get nothing back, because we know we're looking for the right operand of an operation, that can't be right. So we return an error. And that's how we make an operation. And then in order to make this all work, we also had to go back to our definition of a statement. So parseNext is basically looking for statements, looking for the next statement, basically. And if we got a semicolon, we're okay. If we got some kind of expression like a while that wasn't followed by a semicolon, then we put back with the token we got out that wasn't a semicolon, and then we say, yep, it was a while, so that's, statement like. Otherwise, we hit some token. We needed a semicolon because we had like a expression like 3 or something. If we want to make a statement out of that, we've either got to finish, we've got to like hit the end of the file, and then it counts as an expression in the way we're doing it now. Or we've got to hit a semicolon. We hit something else. So it's an unexpected token, return an error. And that's that. So we have done some excellent work. I feel like our parser is way better now, because when it hits something unexpected and it's in the middle of an expression, it just says, all right, I finished the expression. And I think that's how it should be. So what have we got here? Nothing new added. So we can just commit minus A, and this is handle. This was quite a change to our parser. So let's just say successfully return expression if we hit something unexpected. Some unexpected token. That's essentially what we're doing. I mean, we also push it back, like give it back so that someone else can see it later. All right. Well, I hope you enjoyed. We're still on our track of trying to type check variables, but we've gone on this side mission of making our parser much more like a real parser. So hopefully that's of some interest. See you next time.